Hello viewers, you are welcome to my YouTube channel. Presenting to you this tutorial, I'm your tutor Patrick Divine. Okay, that is my name, tutor Patrick Divine. And in this video, we are actually looking at geometric progression. We are looking at what? Geometric progression. That is the topic that we are looking at today. That will be our main focus. So in the previous video, we actually did arithmetic progression. So this time around, we are going to move on and do geometric progression. I hope you all understood that other topic that we did. So before we solve everything, before we start solving geometric questions, so you need to know the difference between arithmetic and geometric progression. So we need to know the difference between geometric progression as well as arithmetic progression. Okay, so this is an example of geometric progression. So it is this is an example. Okay, this is an example. So if you want to find the common difference, so the common difference for geometric progression, it is given by this formula. Okay, this is it. So it is given by this is the common difference. So it is denoted by R. Okay, so the formula, it is what? It is term 2. Okay, term 2 divided by term 1. Okay, if you want to find the common difference. But in AP, we're actually finding this is the common ratio. Actually, this is the common ratio. Okay, R-right is for the what? For the common ratio. Now, for the common difference, this is AP. For AP, you look for the common difference. This one, which we were doing like this. So the common difference in the previous video, we are saying that it is term 2 minus term 1. So the difference is that in here, we actually divide the terms. But here, we subtract the terms. So this is the common difference. This is the common ratio. A ratio, that is why you divide. Okay? In a ratio, you divide. Difference, you subtract. So if you want to find the common ratio for this one, for the GP, you divide the second, you divide this is the second term, then you divide the first term into it. Okay? So that is what you do. Then here, you subtract the terms. So that is the difference here. So meaning that it is going to be 8 minus 5, like that. Okay, so that is what you do. So now, the difference is that if you try to divide this one, if you try to divide, it won't give you the same answer. So this is the constant answer. So if you divide this one by that one, if you divide this by that, if you divide this by that, it will give you 2. Even here, if you divide 12 into 24, it will give you 2. 48 into 24 into 48, it will give you 2. Okay, but here, if you try to divide, it won't give you. So 8 divided by 5, it won't give you that. Okay, it won't give you a constant answer. So if you divide this one into that one, it won't give you a constant answer. So that is how you should know their differences. Okay, so today we are actually looking at geometric progression. So that is our main focus for today, geometric progression. So that is our main focus for today. So this is a sequence that we have right here. So under geometric progression, what you need to know the formulas. Okay, you need to know the formulas. You need to know the formulas about geometric progression. You need to know the formula for the nth term. You need to know the formula for the common ratio. You need to know the formula for the sum. Okay, so the formula for the sum. Okay, just for a recap of those that didn't do arithmetic progression. So the formula for the nth term, we are saying that it is nth term. Okay, nth term is equal to a plus n minus a plus open bracket, okay, n minus 1, then d. This is what we are saying. Okay, so for this nth term now in geometric progression, under geometric progression, the nth term formula, it is equal to a r to the power n minus 1. So you should know this. You should know this formula. It is what? A r to the power n minus 1. So a, you already know that it is the first term. R, it is the common ratio. Okay, r is the common ratio. Then n, it is the number of terms, minus 1. That is the formula. Okay, so that is the formula. So the nth term is for the geometric progression is actually different from the arithmetic progression. So this is what we are focusing on today. So if they give you a question saying that you should find the so this is term 1, term 2, term 3, term 4, term 5. Okay, so you should find the fifth term. Okay, the fifth term, which is the one which is on number 5. Okay, let's try to find the fifth term using this formula. The fifth term, so you know that the fifth term, this is the formula that we have written. So we know that the fifth term is what? Is 48. But just say, let's say we don't know it. Let's say we don't know it. So the fifth term, you say fifth term. Okay, you are looking for the fifth term, like that. So a, it is what? It is the first term. So you get the first term as 3, like that. Okay, as 3. Then the common ratio r. So r, for the common ratio, this one is equal to term 2. Okay, term 2 divided by what? Term 1, like that. That is how you do it. Term 2 divided by term 1, like that. Then it's equal to term 2. Term 2, it is what? It is 6. Term 2, it is 6. Then term 1, it is what? Term 1, it is 3. So the answer, you find that it's what? It is 2. Okay, so here you just put r there, like that. Then to the power n, you know that it is the number of terms. So the number of terms is what? Is the fifth term. Okay, so you put 5 minus what? Minus 1, like that. 5 minus 1. Then you go on, you solve. So that is 3 multiplied by 2. 5 minus 4. What is 5 minus 4? 5 minus 4, it is 5 minus 1, it is actually what? It is 4, like that. So you can't multiply from here. You can't multiply if you haven't you are not done with the power 4 there. So you need to do it from there. So what is the answer? What is 2 to the power 4? 2 to the power 4, it's just written as 2 times 2 times 2 times 2, like that. So that is 2 times 2, that is 4. Then 2 times 2 again, it is what? It is 4. So that is what? That is 16, like that. Okay, so 2 to the power 4, it is actually 16. So mean that you're going to put what? You're going to put 16 in here, like that. Then you're going to multiply 3 times 16. So 3 times 6. So 3 times 6. So 3 times 16. So 3 times 16, like that. So you're just going to do it. Simple mathematics. 3 times 16, we actually multiplying starting from here. So 3 times 6. 3 times 6, you find that the answer is what? Is 18, like that. The answer is 18. So you get 8 remainder 1. So then 3 times 1, that is 3, plus 1, that is 4. So meaning that the answer is what? Is 48. And here there was 48 here, right here. There was 48 right here. So meaning that is how you find the what? How you find the number of terms. So that is how you find the number of terms. It doesn't matter the kind of number of terms that you'll be given, but that is how you should do it. That is how you should do it. I hope you have understood on how to find what the common ratio and the first term, the common ratio and the number of terms. Let's say we are given a question saying that you should find the let's say the 17th term. Okay, the 17th term. So you're going to do the same thing. So 17, you write 17th term like that is equal to a, the first term. A is 3 like that. Okay, a is 3, open bracket, this is r. The common difference, we know that it is 2. Just write 17 minus 1 like that. So you do the same thing. Okay, so that is how you can do it. So let's try to look at another example. Let's try to look at another example. Okay, so let's say we have this. Let's say we have this geometric sequence here as 5, comma, negative 15, comma, 45, comma, negative 135. Okay, so you can actually find the number of terms through the same way. So let's say you want to find the third term. Let's say you want to find the third term or any other term. So, or the fourth term, if you want to get convinced. Let's say you're given the question to find what the fourth term, and the fourth term is, let's say you're not given the fourth term right here. You're not given the fourth term. Okay? So, the way you can find the fourth term is by saying the formula is for the nth term is n. Okay, nth term like that is equal to a r to the power n minus 1. So make sure that you know this formula because it won't be given to you. So you know that for the common ratio, the formula is term 2 divided by term 1 like that. So what is the common ratio? Here we have negative 15 as our term 2. Okay, negative 15 as our term 2, then divide by 5 as our term what? Term 1. So you find that there it will give you what? Negative what? Negative 3 like that. Alright? So this is just one and the same. This is just one and the same thing. So if we say term 3, okay, if we say term 3 divided by term 2, it's just one and the same. So let's say 45, that is 45, that is term 3. How about when we divide it with term what? Term 2 like that. So you find that it is going to enter into that 45. 3 is, 15 is 3 times into 45, mean that the answer is going to be negative what? Negative 3 like that. Okay, so make sure that you should know this formula. You should know this formula. So we found that the common ratio r is what? Is negative 3. So you can actually go on and solve. So what is a? A, it is the first term, which is 5 like that, then multiplied by negative 3 like that. Okay, so then to the power, we are looking for the what? The fourth term. We are looking for the fourth term. Let's say we are looking for the fourth term like that. So we know that this is the number of terms, so you just put 4 minus 1 like that. What is 4 minus 1? What is 4 minus 1? So you're going to have 4 minus 1, you're going to have 3 like that. So then they're actually telling us that we should, what is 3 to the power 3? So 3 to the power 3 is actually 3, negative 3 multiplied by negative 3 multiplied by what? Negative what? Negative 3 like that. So this is what it means. So what is negative times negative? Negative times negative, you find that the answer is positive. Then 3 times 3, you find that the answer is 9 multiplied by negative 3 like that. So positive times negative, it is negative. 9 times 3, it is what? It is 27 like that. Okay, so meaning that negative 3 to the power 3, you are going to have negative 27. So here we are going to multiply by what? Negative 27, like that. Okay, as simple as that. So this is not even hard, you know, these are marks that you cannot fail to lose. Okay, so this geometric progression, it only comes in paper 2. So you should know that the one that comes in paper 1 is arithmetic progression, and the one that comes in paper 2, it is geometric progression for the G12 exam. Okay, so here now you can actually multiply 27 by that. So 27 by 5. So you just do the same simple mathematics. This is like this. Okay, by 5. So you're going to multiply 5 times 7. You're going to find that is 35. So you put 3, you put 5, carry 3. Then 5 times 2, that is 10. 10 plus 2, that is what? That is 13. So when a positive number is multiplying with a negative number, the answer has to be what? To be negative, like that. So meaning that the fourth term is going to be negative 135, like that. So that is how you find the number of terms. So now that you've known how to find the number of terms, okay, now that you know how to find the number of terms, so let's actually look at what we call the sum. Okay, so make sure that you finish this video so that you can actually know what you are doing, so that you can know what you are actually doing, because I'm going to cover everything about geometric progression. I'm going to cover everything about geometric progression. Okay, so we are going to look at the sum. Okay, we call it the partial sum of geometric progression. The partial sum of geometric progression. So you want to find the sum. Therefore, the formula for the sum of the geometric progression. This formula for the sum of geometric progression. This is the formula. Okay, is equal to. Alright, it is equal to A. Okay, open bracket like that, then 1 minus r to the power n, close bracket, then it is divided by 1 minus r, like that. So that is the formula for the what? For the nth term. For the formula for the geometric progression. For arithmetic progression, remember we said that for arithmetic progression is equal to n over 2, open bracket, we have 2a plus n minus 1, okay, like this, then g, like that. So this is a formula for the sum of what? Of arithmetic progression. But now we are looking at geometric progression. Don't mix things. So this one only comes in paper 1. So this one only comes in what? In paper 1. This one only comes in paper 2. So don't mix things. Don't be confused. Actually, this formula, this one which is in paper 2, you'll be given the formula. You'll be given the formula in your exam. It will come. You'll be given the formula. So the only thing that you need to know about this formula is that for the sum there are 2. Okay, there are 2 formulas for the sum. So the other one, you only use it when this common ratio is less than 1, and the other one when this common ratio is greater than 1. Okay, so this one we actually use it when the sum is, when the common ratio. So this formula we only use it when the common ratio, this common ratio, okay, this common ratio is less. When common ratio is what? Is less than 1, that is when we use this one. What do I mean it is less than 1? What do I mean it is less than 1? when it is less than 1, that means that it is smaller than 1. It is smaller than 1. Okay, it is smaller than 1, like 0 point something, negative something. Okay, so all the numbers ranging from 0 something, negative what, but they are not greater than 1. They are not bigger than 1. So we use this formula. If the common ratio is less than 1, we use this formula. If the common ratio is greater than 1, meaning that starting from 2 going up, okay, starting from 2 going up, the formula that you are supposed to use is this one. Sn equal to A, open bracket, 1. So here, the only thing that will change here, it is what? It's going to be R to the power N minus 1, okay, over what? R minus 1, like that. So this one is when R is greater than 1, meaning starting from 2 going up. So the difference is that this R has just come this side. So here it was this side, okay, here it has just come this side. So that is how it's supposed to be. So these formulas you'll be given, don't worry, you'll be given the formulas in the formula section. You'll be given these formulas. You will be given these formulas. So that is the formula for the what? For the sum. That is the formula for the sum. So now the formula for the sum, let's say you are taught to find the sum of over the fifth term, or the sum of the fourth term, 1, 2, 3, 4. So the fourth term. So the sum of the fourth term, how you can find the sum of the fourth term without using this formula, you can actually, the sum, it means the addition of all these. So mean that you're going to add 3 plus 6 plus 12 plus 24, okay? You can add all these. You find that, let's try to punch them on the calculator to be fast, but you're not supposed to use the calculator. So that is 3 plus 6 plus 12 plus 24, like that. You find that it's what? It is 45. That is the sum. It is 45. Okay, it is 45. This is the what? The sum of the what? The fourth term, 1, 2, 3, 4. The fourth terms. All right, the sum of the fourth term. Now let's try to confirm the answer with this formula. Let's try to confirm the answer with what? With this formula. Suppose you are taught to find the sum of the what? The fourth term. The sum of the fourth terms, like that. So let's try to confirm the sum of the fourth term using this formula right here. Okay, let's try to confirm using that formula right there. So so we said that the sum of the what? The fourth term, it is what we are looking for. So here we are going to say equals A. It is the first term. What is the first term? The first term here, it is what? It is 3. So it is what? It is 3, like that. Then you open the bracket, 1 minus, what is R? What is R? So R here, we said that R is equal to what? It is equal to 2. We found 2. 6 divided by 4, or 6 divided by 3, that is what? That is 2. So here we just put 2, like that. Okay, we put 2. Now number of terms, this is 4. So n is the number of terms. So we just put power 4, like that. Then it will be what? 1 minus the common ratio. This one we had found, it is what? It is 2, like that. So that is what you do. That is what you do. So right here, if you look at this one, so meaning that this formula that we are using, it is not the correct formula that we are supposed to use. It is not the correct formula that we are supposed to use. Why? Because the common ratio, we actually said that it is what? When we use this formula, when the common ratio, it is what? It is less than 1. Now the common ratio is what? It is greater than 1, meaning that the answer that it will give us, it will be negative. Okay, and it's not supposed to give us negative. So meaning that we are supposed to use this formula, the other formula that I gave you. Okay, the other formula that I gave you. Since the common ratio since the common ratio is greater than 1, so the common ratio is what is greater than 1. So the common ratio is which is r is greater than 1. So the formula that we're supposed to use when it is greater than 1, so you'll be told that this formula, they will write the common ratio is greater than 1. This formula, the common ratio is less than 1. So when it is greater than 1, you actually use this formula. Sum of the nth term is equal to a, open bracket, you have r to the power n, there is minus 1 like that, then you divide by r minus 1. So this is the formula that we're supposed to use. So we are finding the sum of the fourth term. Okay, the sum of the fourth term, we have a as our first term, which is 3, open bracket, r, we had found that it is 2. So now n, it is the number of terms. So the number of terms is what? Is 4, like that, minus 1 like that. Then r, it is what? It is 2. Okay, r is 2 minus 1 like that. So we can solve now. So this is 3. So you start with the ones that are in the bracket first. So that is 2 to the power 4. 2 to the power 4, it is what? It is 16. So 2 to the power 4, you find that it is 16 minus 1 like that. Divide by 1 minus 2, or 2 minus 1, you find that the answer is what? The answer is 1 like that. Okay, you continue solving. So that is equals 3 multiplied by 16 minus 1, that is what? That is 15. Divide by what? By 1 like that. So this 3 times 15. So 3 times 15, you find that it's what? It is 45. 3 times 15, it's 45. And when we put divide by 1, it will just give you 45 like that. So we've confirmed that this is the answer, right? So this is the answer. Look at this one. This is the answer that you had found like that. So we were adding. So now when you are given that you should find the 10th term. So this is the formula that you are supposed to use, because you don't know these other terms, so you can't find these terms. Then you start adding, it will waste your time. So the simplest formula to use, it is just this same one. Suppose you have these values, you have the first term, you have the common ratio, you have the number of terms, just like that. You'll be able to calculate the the sum of the of geometric progression. Okay, the sum of geometric progression. Now the other thing that we are going to look at is so we are going to look at the sum to infinity. The sum to infinity, that is the other thing that we are going to look at here. So under geometric progression, there is the sum to infinity, but under arithmetic progression, we don't have that. Okay, we don't have sum to infinity. Okay, sum to infinity. So the sum to infinity, it is denoted by this like that. Then it is equal to a over 1 minus r, or a over r minus 1 like that. Okay, so this is you can use this formula or you can use this one, but it depends. If the common ratio is less than 1, okay, you can use this formula. If the common ratio is greater than 1, you can use this formula. So that is the thing to note on this. Okay, so this is the formula for the for the sum to infinity. That is it. So the common ratio that we have here, it is what? It is greater than what? It is greater than 1, because the common ratio that we have right here in this sequence, it is what? It is 2. That is our common ratio. So meaning that we are supposed to use this one to find the sum to infinity. For us to find the sum to infinity, means that we are supposed to use this formula. So if you want to find, you'll be asked find the sum to infinity. So sum to infinity like this, it is equal to what? It is equal to a over Since the common ratio is greater than what? It is greater than 1 and it is 2. So you use this one, which is you put r minus what? Minus 1, like that, so that it shouldn't give you a negative. So we know that this is what? The first term, it is what? It is 3. So the first term, A is for the first term, you know that the first term is 3, then over, what is our r? R is 2. So you put 2 minus 1, like that, equals to 3 over what? Over 1. 2 minus 1, it is 1. So you find that the answer is what? The answer is what? It is 3, like that. 1 into 3, it is 3. So that is how you find the what? The sum to infinity. That is how you find the sum to infinity. So that is what you are supposed to do when finding those things. So now let's try to solve an exam question about geometric progression. Let's try to solve an exam question about geometric progression. Okay, so now we solve an exam question, okay, in geometric progression. Okay, so this question came like this. So we have this question. It is saying that the third, okay, the third, this is 3. So the third and fourth, okay, the third and the fourth terms of GP. I said that GP is geometric progression. Of GP are, there is 4 and what? And 8 respectively. Okay, respectively, like that. Then the question is find. So our number 1, the question is given by, we should find the first term and the common ratio. The first term, okay, so we should find the first term and the common, okay, the common ratio, the common ratio, like that, the common ratio. Okay, so we are asked to find the first term and the common ratio. So then the question 2, so question 2, we are given that we should find the sum, okay, the sum of the first, okay, the sum of the first 10 terms, okay, then the third one and the last thing that you should find what? The sum to infinity. So this is how the question comes. So this is the one way in which these questions come. Okay, so here we'll say solutions. We start by finding A, like that. We'll start by finding the first one. Now let's check. Okay, so now let's check. Right, so the question is actually telling us that the third term, okay, the third and the fourth, okay, the third and the fourth terms, the one which is number 3 and the one that is number 4, okay, so number 3, 4, so 1, 2, now 3, 4, okay, the first, the third and the what? The fourth term of GP, okay, are 4 and 8 respectively. So this statement means that 4 is the what? 4 is the third term, okay, and 8 it is what? It is the what? The third term, the fourth term. So these are actually written like this, meaning they're actually written like this. So here there's here there's the first term, okay, the second term like that, then the third term which is 4, then comma the what? The fourth term which is what? Which is 8, like that. Then that is how it is like this, okay. That is how this sequence is like that. So we are asked to find what? We are asked to find the first term, okay, the first term and the common ratio. We are asked to find what? The first term and the common ratio. So how do we do that? How do we do that? So the common ratio, we can actually find it by using this one, these two, okay. So the common ratio, we know that the formula for the common ratio is equal to term. So we have term 4 and term 3. So we can actually put term 4 divided by what? Term 3, like that. So you find that term 4 it is 8 divided by 4. So the answer, it is going to give you what? This into that, it's going to give you 2. Okay, that is the answer there. That is the answer right there. So now we know that this is the common ratio, right? So then we are asked to find what? The first term. We are asked to find what? The first term. We are asked to find the first term. We know that the common ratio is this one. So the formula that we can actually use is, it is the formula for the nth term. What is the formula for the nth term? So the formula for the nth term is nth term is equals to a r to the power n minus what? Minus 1, like that. Okay, so we are trying to find what? So we know that a, it is what? The first term. This is what we are trying to find. Are we together? So this is what we are trying to find as the first term. Then r, we know that it is 2. Okay, we had found 2. R, we know that we had found 2. Okay, so n, it is the number of terms. Okay, so let's say we are trying to find what? The third term. Okay, let's say we are trying to find the third term. You can use even the third term or the fourth term. So let's say we are trying to find what? The third term. So the third term, we are trying to find the third term, like this. We are trying to find the third term. Okay, so the third term, you know, you are given the third term is what? Is 4. So you can actually put 4 is equal to a, it is the one that you are looking for. Then r, it is the common ratio, it is 2 that we have found here. So r, you can put 2. So we are saying that we are finding the what? We are finding the what? The third term. So the third term means that the number of terms, we are going to put what? 3 minus 1. We are going to put 3 as the number of terms, like that. So it is going to be like this. So here now you go on, you find 4 is equal to a, open bracket, 2 multiply 3 minus 1, that is 2. Okay, 4 is equal to, just like that, this is a multiplied by 2 to the power 2 to the power 2. 2 to the power 2, you find that it is what? It is 4. Okay, so then you are trying to find a. You are trying to find a, mean that you are going to divide both sides by what? By 4, like that. So mean that this one will go, mean that a will be what? A will be what? Will be 1. 4 into 4, it is 1. So 4 into 4, it is what? It is 1. So that is how you find the what? The first term. That is how you can find the first term. So the first term, we know that it is 1. So you can actually use this same one. You can use this one if you want as the fourth term. Okay, so this is first term, second term, third term, fourth term. So we know that here it is what? It is 1. You can do the same thing to find what? To find this. Okay, so you can do the same if you want to find that. If if you want to find the second term, but we are not requested to do that. I hope you've understood what I've done here. So that is question 1. So meaning that we have answered question 1. We know that the first term is there and the common ratio is there. So now we are taught to find, this is question 2 now. We are taught to find the sum of the first 10 terms. The sum of the first 10 terms. So we are solving question 2. Like that. So let us look at our formula here. Let us look at our common ratio. Is our common ratio less than 1? No, it is greater than 1, meaning that the formula that we are going to use for the sum, it is n is equal, sum is equal to what? A, open bracket. I said that when it is greater than 1, we use this minus 1 like that. That is what we do. R minus 1. So this is the formula that I showed you. So we are trying to find what the sum of the first 10 terms. Okay, so the sum of the first 10 terms. So we know that the first term is 1. Okay, the first term is 1. Then open bracket. What is R? R, we know that it is 2. We had found 2. So we just put 2 to the power n. N, it is what? The number of terms, which is 10. So it is 10. Okay, then here there is minus 1 like that. Over what? R, which is the common difference. Okay, R is the common difference. So R, it is 2 like that. Minus 1. 2 minus 1 like that. So that is 1 multiplied by, what is 2 to the power 10? Okay, what is 2 to the power 10? So this one, I said it comes in paper 2, and in paper 2 you'll be using a calculator, so you don't need to worry. So this is a calculator right there. So you say 2 to the power 10. So the power is actually here. Okay, the power is actually here. So I said 2 to the power 10, like that. So it is 1024, 1024, like that. So you put 1024 like that. Then there is minus 1. Okay, so you just say minus 1, then it's over. This is 2 minus 1, that is actually 1. Okay, so we continue. So here it is showing that we should subtract 1 from it. So that is just minus 1. So that is 1023. So 1020, so meaning that it's going to be sum of the 10th term is equals to what? 1023. It's going to be 1023. So this is the sum like that. Because when you subtract 1 from it, you need to multiply it by 1. Okay? It is just the same answer that you're going to have. And when even you divide it by 1, just the same answer that you're going to have. So the sum is what? Is this one. This is the only answer that you are supposed to find as the sum. Okay? So that is how we find the sum. Make sure that you should know that formula. Make sure that you should know that formula. But it is actually given in your exam paper. You find it. So the other question is saying that find sum to infinity. Find the sum to infinity. So we know that the sum to infinity, it is like this. You find it on the formula part. The formulas, where you find the formulas, right there on the part where you find the formulas like that. Okay, so we know that it is A over. So if the common ratio is greater than 1, we say R minus 1. If it is less than 1, we say 1 minus R. So the first term, we know that it is 1. Okay, we had found that it is 1. That is our first term. This is just 1. R, it is 1. So you just put 1. Or you just put, this is the common ratio, which is 2 minus 1. Okay, so we know that it is 1 over 1, which is actually 1 as the answer. As simple as that. So you get all these marks. So this question came as 7 marks. It came as actually 3, the first one is 3, the second one is 2, and the third one is 2. So mean that is 4 plus 3. 4 plus 3, it is 7 marks. So you can't lose these 7 marks. So that is how you can find it. Let's try to look at another example. Another example that came in a certain paper as well. So this question actually came in 2017. Okay, that is the question that we are going to solve. It came in 2017. Okay, so it is saying that let me rub this part. So it is saying that the first 3 terms of geometric progression, are, so I won't write the words. So the first 3 terms, so this is term 1, 6 plus. So the first term is 6 plus n. Okay. The second term is 10 plus n. Then the third term, okay, and the third term is what? The third term is 15 plus what? Plus n. Okay. So 15 plus n. That is what, this is the first term, second, the third. Alright. So now we are asked to find what? The value of n. The value of n, that is our first question. The value of what? Of n. Okay. The value of n. The value